Welcome back to another Learn PowerShell video. We're going to be covering day 3 of the Advent of Code. The subject is binary diagnostic. So let's just jump right in. Again, I'm not going to cover the story. I'm just going to kind of cover what the problem is, and then let's talk about coding it. You can always pause or sign up for Advent of Code yourself to read the story and follow along and code all of these on your own with your own code and your own puzzles. So we're going to get a binary puzzle that's going to look similar to this. And what we need to do is decode them properly. So the first parameter to check is the power consumption, and you need to use the binary numbers in the diagnostic report to generate two binary numbers called the gamma and epsilon rate. Power consumption can be found by multiplying the gamma rate by the epsilon rate, so we know at the end we're going to have to multiply two numbers again. So each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all the numbers in the diagnostic report. For example, here using this puzzle input, considering only the first bit of each number, there are 5 bits and 7 bits. So 5 for 0 and 7 for 1. Since the most common bit is 1, the first bit, so there's 5 zeros and 7 ones. First bit of the gamma rate is 1. So what they're talking about is right here. So you have 0, 0, 0, 0, 0. That's 5 zeros in the first position and 7 ones. So since the most common occurrence in the first position is 1, then our gamma rate is going to be 1. The second most common bit here in the second position is 0. So that for the gamma rate is going to be 0. So the gamma rate after doing all this is 10110 for these, or 22 in decimal. So right here, we can see that we need to convert this binary number to an integer decimal of some sort, because we need this to do math, because you can't multiply you could multiply binary numbers, but you wouldn't get anything legible out of it. So the epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit for each position is used. So the epsilon rate is just this in reverse. So 10110 is 01001, or 9 in decimal. So multiplying the gamma rate 22 by the epsilon rate 9 produces 198 as the total. Alright, now let's go back over to VS Code and check it out. Alright, so you'll see here that I've already pasted a URL here for you. So this URL is how to easily convert decimal to binary and back. So this is necessary to accomplish today's task. It's something that we haven't covered before using the convert class, and I just want to post this here. It's also going to be in the description, so you don't have to pause it and try to read this or retype this. You'll just be able to click the link in the description. So firstly, we need to go ahead and input our puzzle, which I have right here. So let's load that up. So let's go ahead and take a look at what that puzzle looks like. So if you remember from the video, or from the page that I just had up, the binary number was only about, I think, 6 characters long, 7, something like that. The input we have is actually 12 characters long, so it's a lot more complex than the initial example, which is always to be expected for Advent of Code. So first thing that we want to do is, we know that we're going to have to actually look at each position of where we are in space or in the string. So what we need to do is create a lookup table, because we need to just look up which position has which numbers in it. So to create a reverse lookup table, in 90% of all cases I've done this, use a hash table. So you can just initialize an empty hash table, because we're going to dynamically create all of our entries in here. So for each line in the puzzle, we're going to start by initializing in at 0. And we're going to kind of do this in a nested fashion, which is probably not ideal if you're familiar with coding. However, I think this is the easiest way to explain it from my point of view. So we'll initialize in at 0 because we're going to increment through this for each entry. And I'll show you what I mean by that in a second. We're also going to need to break out. So right now, if I just look at this and then show you. So if I look at the line, I have it like this. So there's a couple things we need to do with this. And obviously, stepping through this by itself is fairly simple. We're just going to need to split each thing, or we can look at just each position, which is probably just the same. Maybe even a little less code, but maybe a little more complicated if you're a beginner. So what we're going to do is we're going to split each of these into its own array. So we can do something like line to char array, and that breaks out everything for us. So that's simple. Or we can also do using the split method, which I've shown you guys a couple of times. So I'm going to stick with the split method just for the sake of this video. So we're going to create a bit array, and we're going to say line split, and we're going to split at nothing, which will split every character just like character array did. So let's do this. And I'm doing it this way to show you guys this issue. So you'll see here that at the end of the character array method, there is no empty space. However, splitting, there's an empty space. Some people will tell you just need to trim. However, even if I trim, there's still empty space because it's not actually an empty space at the end of this, it's just adding an empty space. So we can't just trim it. So what you can do is use where object, and you can say where object does not equal just blank space, and this will actually remove that empty line. Again, this is the exact same process of just using two character array. However, I want to show you guys how to handle white space, how to get rid of it, and keep something that we've been using already with string manipulation, just to kind of reiterate how we're doing this and the multiple ways that you can handle things, because I want you guys to learn. So from here, we're going to nest it now. So what's happening is now we have all these items in their space, and we are going to say for each bit in bit array that we just created, we are going to say that our bit count, calling our hash table, and whatever position we're in space. So we start at n0, and we're going to make that whatever bit it is. So if it's a 1, we're going to add a 1 to it. If it's a 0, we're obviously going to add nothing, but it still counts as adding something. So for this first one, we're going to add 1 to position 1, we're going to add 1 to position 2, 1 to position 3, and 0 to position 4. I will explain why we're doing it this way in just a moment. But first, we need to then increment n by 1. So every time it runs through this, it'll increment and move on to the next number. And then before it moves on to the next line, it will reinitialize n to 0. So let's run this and see what we're looking at. So here we have our bit count. So we have the name, so the 11th bit, which is the 12th number, the last number in the series. So in this case, for the first line, it's a 0. The value of that is 521. In the first space, it's 501. So why I did it like this? Because we can just do some very simple math to figure out if there are more 1s or more 0s. Obviously, we're only dealing with on or off, yes or no, 1 or 0. So we can just divide that by half and figure out which is greater. If the number is less than half, then we know that there are more zeros than ones. If it's more than the total half, then we know there's more ones than zeros. Just a quick look at this, there is no position where we have a tie. So obviously you could handle this with a tie if you needed to, but we would have to have strict instruction on what to do in that scenario. Do we handle it as a 1 or a 0? Because remember, we have to flip it for the opposite. So we have gamma is 1, 0, 1, and then that makes epsilon 0, 1, 0. So we would need strict instruction what to do in a tie. Obviously, because we don't have that issue, we don't have to address it. So let's just say that we're going to take our puzzle count and divide that by 2, and that'll give us our halfway point. And our halfway point happens to be 500. So 501 and 501 are the closest we get to that, and that you can clearly see those are both instances where 1 is the answer for that position. So now let's make an empty string called gamma, and an empty variable called epsilon, where it is also just an empty string. And I'll explain why I'm making it a string here in just a moment as well. So now we need to then figure out which is which. So for each n in 0 through 11, so for each position in the bit count that we've done, we are going to step through it. So our position is going to equal our bit count n. And then we just need to figure out if this position is greater than or less than the halfway mark, because this bit count n, let's see, what is n equal right now? Let me just initialize n to 0, because that's, whoops, to 0, that's where we're going to start. So if I run this, our bit count is 501 for position 0. And remember, this is just typing this. And this is going to keep incrementing by 1, so we can step through this entire hash table. So and that's our position. So then we just need to figure out if it's greater than or less than the halfway point. So if the position is greater than half, because we know the half is 500, then we're going to say gamma plus equals 1, 1, and epsilon plus equals 0. And why am I doing it like a string? Again, I said I'd explain this. If I just add 1 to this empty variable, what it's going to do is keep incrementing and count up to exactly what we have here. We don't want that. We want to know what the final string is in binary form. So to do that, we have to actually change the positional string, so that way it's not going to add to it, it's just going to keep adding to the string in sequence. So let me do this. Plus equals 0 and epsilon plus equal 1. So if it's less than half, this is going to happen. So let me illustrate this really quick. So if I look at gamma, we have a well string. And if I look at epsilon, it should be exactly the opposite. So it should be 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0. So there you go. So that is exactly the opposite. So now what we need to do is then convert these binary numbers to an integer. It says to decimal, but we're going to just convert to integer because we're just multiplying, so we don't need the decimal class, because decimal just handles really large or really small numbers. Int 32 is going to be fine because we're not going crazy with the number that we're going to end up with. So what we're going to do is call this our gamma number, and we're going to say convert. And to access these classes, use double colon, and then you tell it what are you converting it to. So we're going to convert 2 and 32. We're just going to say we're going to convert gamma and 2. So I will also paste in the description the Microsoft Docs page for convert if I can find it. Hopefully I can, just so you guys can read up on the second option right here. So we're going to call this epsilon number, and we can just copy and paste this. No reason to reinvent the wheel. Epsilon. So if I run these two, now our gamma number is 3,827, and our epsilon number is 268. So now we just need to get the final number, which is our gamma number times our epsilon number. Whoops. And our final number is 1,025,636. And I will switch back to this, and you can see here that our input is 1,025,636, and I have part 2 enabled, so you can see that my answer was correct. So that is the first part. The second part is rather involved, and this is already a 14-minute video, so I'm probably going to break this video up into 2 parts, especially since I still haven't solved day 4 and we're on day 5. Obviously this video is a day late. Pretty busy yesterday, so I'm going to post this in 2 parts and hopefully then be able to play catch up by posting 2 videos in one day if I ever finish day 4. I haven't even looked at day 5. Alright, so thank you, and I'll talk to you soon.